All right, so let's get started. Can everybody hear me okay? Okay. So we're going to talk today about attacking Windows Communication Foundation, or really services that use WCF to talk to clients. So just a quick overview as to the outline of the talk. The objective is really just to talk about different tools, different ways you can either attack an application or pen test an application that uses WCF, and also ways that you can potentially abuse some of the WCF bindings to do stuff. So we're going to talk about just a little bit of overview as to background on WCF, and then we're going to go through three scenarios. One is going to be a Silverlight application that talks to a WCF service. Another one is going to be some interesting stuff around WCF duplex services, and we'll talk a little bit more about what that is. And then we're going to talk about WS security and some of the security options that WCF has that makes, from an attacker's perspective, things a little bit more difficult, but certainly not impossible. So WCF is really the core communication framework going forward for .NET applications. So the interesting thing from an attack perspective is that the only new thing that complicates life from a remote attacker's perspective is the different bindings and protocols and message formats that the web service expects. And what we're going to see here is a lot of the tools out there, or the classic web services tools, do not support a lot of this stuff. So it becomes a little bit tedious trying to figure out how to talk to the service. This is just a diagram that I pulled from one of the Microsoft sites, and really the message here is that you can see all the different legacy communication mechanisms that .NET had and Windows had, and really what they've done is they've tried to roll them all up into one framework that allows you to then talk to, basically talk to anything from any .NET service. So it's pretty cool stuff. The key here is that when you talk about a WCF service, there's really three things that you normally hear about, and a lot of times they call these the ABCs of the WCF endpoint. So there's an address, a binding, and a contract. And really what we're most interested in is the binding. The address is important too, but the address is really just the URL or the location where you can find that service. So it's pretty standard. You can see the notation there. It's just like a URL that you'd expect to plug into to a browser. You've got the transport, the machine name, if there's a port number that's not running on a standard port, and then potentially a URI. And one of the ways you can always tell when you're talking to, or a good giveaway that you're talking to a WCF service is, if you remember back in the legacy .NET web services have the .asmx file extension. A lot of times you hear those referred to now as ASMX services. So a WCF service is going to have a .svc file extension by default. It doesn't have to, but more often than not, that's what you see. So if you're looking at a web service and you see a .svc file extension on a web server, that's probably a WCF service that you're talking to. The binding is really the key thing that we need to think about from, or we need to know about before we attack the service. So the binding defines not only the protocol that's going to be used, and there's a bunch of different protocols that are supported out of the box, but also the message format, the encoding of the message that's going to be used as well. So I've got a slide here of just some of the more common transport protocols and message formatting options that WCF supports. From a remote attacker's perspective, if we're talking about something on the internet, you're probably going to deal with mainly the ones that are highlighted in yellow. And more often than not, you may not even see net.tcp up there. If you're talking about something on the internet, that's more of an intranet binding, but you could certainly see it. It will work over the internet. And then from a message perspective, there's a lot of text-based message formats like SOAP, XML, the stuff we're used to. But then there's a new binary message format as well that's optimized for services that are both written in WCF to talk to each other. And that's what tends to complicate things a little bit. And then finally, the contract. The contract is really just defines what methods, what data types you're able to pass in and out of the service. From an attacker's perspective, you're just going to have to deal with the contract that the developer published. The notable thing here is that it is an opt-in approach. So by default, there is no method that's exposed. The developer specifically has to expose everything. So the good news is Microsoft has tried to to really harden a WCF installation out of the box, you've really got to turn everything on. But as we'll see here in a few minutes, normally most of the developers will tend to go with the common settings that will allow us to do whatever it is we need to do. So I'm going to go through three scenarios, and there's going to be a lot of demos here, so hopefully the demo gods are not going to frown on me today and things work. We're first going to look at a Silverlight 3 application that talks to a WCF service. We're then going to talk about a duplex binding in WCF that you can actually use to remotely turn any WCF service, or not any WCF service, but one that's using this specific binding into a port scanner of sorts. And then we'll go through and look at some of the security settings, the WS security options that can be used as well. So the first example we're going to do here is a Silverlight client service. So starting with Silverlight 3, there's pretty good support for WCF and Silverlight. So by default, if you write a Silverlight application that talks to a WCF service, it's going to be using the .NET binary SOAP protocol for exchanging messages back and forth. And the way you can tell this, if you look at it, if you sniff it, or if you look at it in a proxy like burp or any of the attack proxy tools, you'll see that the content type is actually set to SOAP MS bin 1. And that's basically a proprietary protocol that Microsoft has developed. It's a binary XML message format, and they've published the spec on it up there. But it is intended for Windows or Microsoft components to talk to each other. So there's what I found is, this all sort of originated several months ago when I was looking at a Silverlight application that was using this format, this message format. And what I found is I needed to manipulate the data going into the service, as you typically do when you want to test a web service. And the problem was that I wasn't able to really even see or certainly not manipulate the messages. And most of the tools out there didn't have support. So I looked at Fiddler, which is the one that had the closest thing to support, which is sort of a local proxy tool that you can use. A lot of people are familiar with this. And a guy named Richard Berg actually wrote a binary XML inspector for Fiddler. And this is what it looks like if you were to use it. It actually will show you, and I'll show you in a minute what the raw binary data looks like. He actually converts it to readable XML that you can then view in Fiddler. Now, the key problem here, though, is that this is a read-only interface. So I'm not sure if it's a limitation of the Fiddler API or just a limitation of the inspector that he wrote. I actually went back and forth with some emails on him, and he said it's a limitation in the API that allows him to just to have read-only access to this data. So it's great for looking at the data that's going back and forth, but you can't edit it, and that's sort of a key requirement from an attack perspective. So let's take a quick look at what this actually looks like in the browser and through a proxy. I've got a little test web service. You probably can't see the URL up there, but it's just running on a VM on my machine here. And this is just a sample MSDN sample calculator that they publish. There's a bunch of different calculator examples they have for showing how to do stuff with WCF. So you just put in 3 plus 3 here. You hit the equal sign. The web service then calculates it and returns 6. So if I go ahead and turn, I'm going to use a local proxy called burp, which a lot of you guys are familiar with, I'm sure. And I'm going to go ahead and turn burp on here and intercept this request and see what it actually looks like. So we'll do 4 plus 2. And if I go down to burp, oops, what you'll see here is this is what you actually get in the burp interface. It's a bunch of garbled binary data. You really can't even see the numbers that I typed in there. And if you try to edit this, even if you look at it in hex, it's not actually going to show you the data that you need to see. And the reason for that is, as I mentioned, this is a compact binary XML format that really just puts a bunch of different binary markers into the message instead of the actual XML attributes. So from a test perspective, we need to be able to decode this. So I was looking around. I mentioned that I saw in Fiddler that there was this is an open source component in Fiddler. So I started looking at the code and thought that it would probably port quite well over to burp, which I've written a plugin for before. It has a pretty easy to use plugin interface. And I know that with burp, we'd be able to transform that data as opposed to the Fiddler interface, which would be read-only. So There's a plugin that was written a few months ago. I released it back in November.